The second way how clouds are commonly differentiated is based on the service model they provide. Here's a great image that depicts the differences between the different service models. Without the use of cloud computing, you run your application on-premise, and that means that you have to take care of all of these different layers yourself. You manage them personally, the application, the data, the runtime, middleware, OS, so different components of the software stack, including the virtualization technology, and then the lower level, all of the components of the hardware stack. At the other extreme, you can use cloud computing services and then directly leverage the fact that cloud computing can provide you with an application. So this is a model called software as a service, and this resembles what Gmail offers you. You don't have to run your mail server, install quotas, manage security patches, etc. for the employees in your company. You can just force them to use Gmail. And in fact, you can just contract Gmail to run the the email services for your company. In the case of Gmail, everything is run by Google in this case. It's their hardware, it's their software stack, system software. They own and manage the data. They run the application, configure it, update it, upgrade it, and everything else that's necessary. So this is the software as a service or SaaS model. A second model is where the cloud service can provide you certain APIs that you can access to develop particular types of applications. The cloud service provides a development or execution environment, and that includes the operating system, various libraries, various tools that are necessary for the applications that need to run in that environment. One example is the Google App Engine, and this is called Platform as a Service Offering, or PaaS. In the case of the Google App Engine, the Platform as a Service Offering is that it offers everything that's necessary to develop applications for Android platforms, for instance. Windows Azure was originally purely intended as a PaaS offering for developing and running .NET applications. Then more recently, another type of extension was added to the Windows Azure portfolio of services. Finally, at the lowest level, clouds can provide infrastructure instances, like compute instances that consist of the CPUs, or rather virtual CPUs, with accompanying memory, or storage, or the necessary network resource in order to form a cluster of such compute instances. Amazon's Compute Cloud is an example of such an infrastructure as a service cloud computing model. This can also include other types of hardware resources like GPUs. So you can rent from Amazon instances with GPUs, for instance. Again, note that these types of clouds don't really provide you with the physical resources directly. Instead, the resources are virtualized. And so it may turn out that you are using independently some subset of the physical resources available in that cloud system. But it's quite possible and likely that you're sharing the resources with other tenants. An exception to this is that, in particular in the case of Amazon, they do provide some high-performance instances. So if you're renting through Amazon a cluster of VMs or a virtual cluster or a virtual high-performance instance, you will, in fact, end up with a virtual machine that runs independently on physical hardware. The same thing happens when it comes to the GPUs. Your GPUs won't be shared in this case. But that's just because of some technical challenges in terms of how to get sufficient performance level in a virtualized environment for these high-performance instances or GPU-enabled instances that Amazon provides.